Hi everyone, welcome to the next episode of the GT project. Today we'll be looking at the engine, taking it apart, see what's going on with the compression that we previously discovered is low on a couple of cylinders. So I've got the ancillaries off, carburetors off, etc. So we'll dig into that. For those that haven't met her before, this is Claire, my wife, who's coming in to lend a hand today and learn a bit about what's inside MG engines. So yeah, we'll dig in and see what we find. I've given it a wash down, and surprisingly actually it looks quite nice underneath all the grease and grime. There was a lot of it, but yeah, it's exposed some quite nice paint really, which is unusual. The head's quite gross. There was no thermostat in the stator housing, surprisingly, so someone's obviously had cooling issues before, maybe a radiator issue. There's quite a bit, the block drain doesn't work, so it's really packed with rust, so chances are there's going to be a lot of rusty debris inside the cooling jacket, and we'll probably pop a core plug out at some point and have a look in there. One of the interesting things sort of at the strip down up to this point, the oil filter plate that came off the engine is like that, and it's missing a piece. It should look like that. There's a tube there that sticks up inside the oil filter as an anti-drain back, so the oil filter is always full of oil. Now this engine was missing that. It's got stuck in an oil filter in the past, and it's gone missing, and no one has noticed in subsequent services. Something I do see occasionally. So whenever I see a dead engine, I always take one of these off because you'll find a home for it in the end. So let's get some tools and have a look. Okay, so a cylinder head, for those that don't know, is the top half, really, is the easiest way to describe it, but the top component of the engine itself. So in the bottom half you've got the pistons that go up and down, and then in the top you've got the valves, and these let the exhaust out and the air and the fuel in, and they open at the right moments for the combustion. Now with this engine, the cam is in the block, and these take their movement off of the camshaft, and it pushes up and down on the back of these rockers and opens the valves like that. The issue we have, we think, is with these valves here. So we can undo, first of all, take the slack and the rocker ones off, and then the head bolts, the big main ones that hold the two halves together. There's this huge row then all the way around the outside. In this case with an MGB engine is studs and nuts. We'll undo those in a sequence that doesn't put much stress on it, because you don't want to undo all but one and then it's being pulled down in one area. So you undo them sort of in a pattern slowly to relieve the pressure, because they're held together quite tight. So we'll go around that order, and then we should be able to pull the head off, have a look inside the bores, and then at the bottom of the head and see what we find. So,
can I ask, what sort of things are you looking for or think you might find when you get in? Is there anything in particular you're expecting to see? Or hoping not to.
Well, I don't want to see any scoring to the bores. I want nice, smoothish surface without a lip at the top. If there's a lip at the top, then it shows that there's been wear, because the piston doesn't actually scrape the bore all the way to the top. There's a little bit at the top that's an unswept area, and the difference between that and the piston area gives you an idea about how much wear is actually there. You're looking for a little pitting damage from moisture or from pinking, which is too advanced ignition system, although it doesn't really matter as long as there's not extensive damage. Sometimes you get foreign object damage. Someone drops a nut in it, that nut goes up and down and gets mushed up by the engine. Can happen, not very likely, but it can happen. Looking for recessed valves, so where the valves sit against the head, if there's been excessive wear, the valve actually recedes up into the base of the head, and again could be the cause of our slightly low compression. So when you're slackening off the head studs, you go incrementally from the furthest out, and then you work. The best way to think about it is you work your way in like that, getting closer and closer to the centre. So I tend to crack them off, and then maybe give them half a turn, and then they'll start to all come undone. These have been on there quite a while, a bit rusty the outer ones, so we'll see if I can get these undone without making the whole engine move. There you go. one, and then the other outer one. Work your way in. This is all in the Haynes manual, etc., giving you the right order to do it. So should anyone want to know that I've done countless MG engines in my time, so I just remember what the pattern looks like in my head. As long as you do a little bit by little bit. If you miss one, you'll come back around on the next pass. It's just about putting as least stress on it as possible. So as the rock assembly comes off, which is the next one, which is this top row with all the rocking arms on it and the shaft in the middle, you can check the rocker bushes for wear. I'm too busy thinking about talking as well as thinking about what I'm doing. I had an engine come in from a customer once who'd been told by garages that his engine has had it, he needed us having a reconditioned engine, but it was a matching numbers car, it was really nice. So the guy brought the car in for me to rebuild the engine for him because he wanted to have that engine rebuilt rather than having an exchange one. That's actually pulled the stud out the block, where are the camera? Stud out the block rather than the nut off the stud, which can happen. The corrosion has made it stick to the stud, so we have to get that out later. Yeah, anyway, so he'd been told that he needed to have his engine rebuilt. It was really rattly, lacked power, really bad. So he brought it to me to be done. Did a compression test. This compression is lovely, there's nothing wrong with that. It's very, very rattly. So with the compression good, the valve clearances were really far out, but also there was a lot of slop in the valves. These valves were a lot of sideways movement, and that was the noise. So put new bushes inside the rocker arms and fixed it. That was all that was wrong with it. It went great after that. So he opted to have other work done instead. He had the car brought a long distance to come here. So he's like, oh, well, as I'm not paying for all that engine work, I'll have something else done, So all the fixings are now off. Quite a few studs have come out. So now we can get the rocker assembly off. You can, if you don't have all the reaming equipment and stuff, you can get these service exchange if you want to have someone repair the bushings. With MGBs, if you ever swap rocker assemblies, make sure the oil feed hole is, where's the camera? The right one. There's two different types. One of them's offset, one of them's straight. Just make sure that it lines up with the hole in the head. Otherwise you won't have any oil feed to the rockers. If you pull a rocker sideways, you can see the area that rocker's been rotating on. It was a bit gummed up, so it's not sliding very easily. Come on. There we are. So you can you see the smooth patch where the rocker's been running on the shaft, and you kind of want to look for a step there if there's been bad oil in it or bearing failure, get bits of metal in the oil, that shaft can get damaged, and also the bronze bushes that are in the rockers. So best thing to do is to strip that apart and see. Chances are that it'll need another one, but be something else to take apart at some point. Push rods then, I tend to keep them in order. I have an organiser that I made earlier from a fuel pump box. So it's best practice to put stuff back in the places that they came out of because they've all worn into each other. So I've got a box with 1, 2, 3, 4 and 2 holes for each one. So cylinder number 1. I give them a little shake because they get stuck in the oil of the lifter underneath. And you can feel it lift the weight of the lifter. So just find a box, stab 8 holes in it. It just keeps them organised, stops them rolling around in the debris. You can check these as well. Not very easy to do now, but if you find a piece of glass or something that's really, really flat, give them a good clean and then roll them down. And if they've been bent or had any issues, then they'll be shaped like a banana. You'll see them wave up and down as you roll them along a flat surface. So that's a good tip to check before you put them back in again. So now with push rods out, all the nuts off, in theory that should lift off, but the head gasket will have sealed it, if the head gasket was any good, to the block. So they can take a bit of persuasion, might need to deploy some crowbarage. Oh no, it does move.
There's a wiggler.
One end's moving better than the other, so I'll just give it a bit of a jiggle. It's quite tight on that stud, I think a bit of rust has gone down, a bit of water or what have you. Look at it. And obviously, these are all cast iron, so they're all really heavy. Just keep jiggling it, and sometimes you can have a bit of head gasket stuck to one thing and not the other, so it moves better in one place than another. Ooh. That end's moving nicely.
Yeah, this corner does not want to go.
No, it's probably stuck to the head gasket still. Ooh.
There is more of a gap. It is coming.
It is. It is. Okay. I'll try and you take that. As I wiggle it, just try and don't pry on it because you might damage the head surface.
Oh, okay.
If I lift it up enough, just stick
Just
it
try and
underneath
get
like
it.
a wedge.
Yeah.
Anything? No.
Not quite enough. No.
Okay, put it under there.
Yeah.
Okay, a little bit.
I'll probably come in from the side now. I'm going to go here. Oh, yeah.
Oh, it's a good job it's not heavy. Woo. More Weetabix for breakfast. It is stuck.
Yeah.
It's very tight around this stud, and I think that's the issue. It's coming up.
There's a good gap now. Yeah.
There it goes.
Go. Oh, there's quite a lot of rusty looking gunk in, but
Okay. Okay, well, the head gaskets come straight off, so it wasn't particularly well stuck. There's quite a bit of corrosion in the coolant way. Yeah, look at that build up there.
Yeah.
Got you. So it's a valve cutout block, which is right. There's little dishes here because this engine is what they call a big valve engine. You can tell by the serial number on the head. The mid ones have the larger inlet valves, and it means they have to have cutout reliefs in the block, so the inlet valves didn't touch.
I see. Yeah.
Okay, so we're looking inside the bore. These are the pistons that go up and down. So when there's the bang of the engine, as it's driving you along, it goes down with the bang. So looking at the stat surface of the cylinder, so I can see honing marks in it, which is great, which means it's not too badly worn. And the lip you're looking for is if you drag your nail up the side of the bore, it shouldn't catch on anything. It should be nice and smooth, which it is, which would indicate to me that that's okay so far. Yes, darling.
What's a bore?
Well, the bore is this circular bit that we're talking about in there.
Does it feel smooth?
Yeah.
Yeah.
Look.
Yeah, you're all goopy already.
Look.
Okay. Another thing we can check is if there's any markings on the tops of the pistons that might indicate whether it's been overbored. I tend to write them on the edge Ooh. Oh, look at that. Excellent. So there we've got plus 030. So what we call plus 30s. So plus 30 thou. So this engine has been machined out 30 thousandths larger. So from memory, that's something like making it a 1838 or something like that. Don't quote me on it. It's been a while since I looked it up. So this engine has been rebuilt before. It's had new pistons. It's been bored, and that's why it's in nice condition there. So we'll turn the engine over because we've seen these two bores which look okay. There's a little bit of pit in there, but it's very small. We'll turn the engine over now. Do you hold that for me? I got something to turn it over. So that's how it goes when it's running. See, it's like that. Once your engine's running, and that's the distributor connected to. Always points at the right one. So, yeah, right. Let's come and stand down here. I'll hold the socket on. You turn it around like that. Turn. Go on. Oh, you need a longer bar. Whoop, oops. Okay, try again. Try pushing down. Probably a bit easier for you to push down. There you go. Got to encourage the young ones. Right. We get it all the way down again. We can have a look at the other two balls. There we go. Okay, so the ridge is there.
What's that?
Tiniest little bit of. I can't feel it with the tip of my finger though. It's just a bit of staining. Sometimes when the valves are open, you end up with moisture getting into the cylinders and giving it damage while it's stood. To be fair, I would just give that a clean up. Other things to look out for once you've got the head off of a B series is to have a quick look at the gaps between the cylinders, because sometimes they can leak compression between them because they're quite close. If you look at the gap between number 1 and number 2, it's very small, and it's just the firing of the head gasket that protects the two, and they can sometimes lose a bit of compression between them. And if you've got two adjoining cylinders with low compression, that can be an issue. Once the top of the block is cleaned thoroughly, I put a straight edge across it, check it for distortion. B series blocks do have also a tendency that people miss a lot, which is where the studs screw in, it can pull up the block around those studs. So you have high points around the bases of all the studs, and you put another head gasket, another head on it, it doesn't actually crush the head gasket very well between the cylinders, and then you end up with the head gaskets going. So when you got a head off, take all the studs off, clean the block thoroughly, and then we'll do that check in another video probably, to check it for trueness and to make sure that there are not high spots. If there's high spots, then you've got to strip it to a bare block and have the block machined flat. I've had that done on quite a few, but it could be as high as 1 in 3 need it doing. They've had multiple head gaskets over their life. The head's been torqued quite a few times, probably for different reasons, over 50 years, and it's often something missed, in that preparation of making a reliable engine. So yeah, that's our checks there for having the head off. We'll have a look at the underneath of the head now and see what we see. Okay, so this is just the head turned over, still got the head gasket on it. Can't say that's stuck particularly well. Could be lack of preparation of the surfaces, really. It depends on the make of the head gasket as well. It says made in England on it. But I can see someone's previous mistake fairly easily. Rear of the head, front of the head.
Oh.
The camera can pick that word out.
Front.
Oh.
Oops.
Oh. The engine weirdly had very high oil pressure. Now, is it, just trying to looking at the holes now, it does have holes in that are symmetrical front and rear cylinders, so it can't have blocked a oil gallery off, do you think?
Oh, symmetrical. Yeah.
Yeah, so there's no, all the holes in the head were exposed, so it wasn't going to cause an issue. It's got duplicates there, probably for that very reason, is if someone was incapable of reading front, that it wouldn't cause serious damage. And another thing, Yeah, if the front was the right way, then obviously that would be the top side, because it would be like that.
Yeah.
Whoops, there it goes. Avoiding issues.
Going.
So, yeah, I mean, I'd say a lack of preparation of the head surfaces, because there's quite a lot of dirt and carbon and kind of stuff on the head surface. And if the head surface isn't very, very clean when the gasket goes on, it can't stick to it, and therefore you end up with the one that doesn't stick as well. And you can see by all this kind of blackness, I would suspect that was the issue. A lot of gross in the coolant ways, serious lack of antifreeze in its life. That's all going to need a thorough cleaning out. The water pump was pretty gross, well, we haven't taken it off yet, but I can guarantee there's going to be grossness inside the cooling jacket. I can't see any impact damage or anything like that, no chipped valves that are obvious. What I would say is that the exhaust valve sits relatively slightly prouder on 1, 2 and 4, and it was 3 that gave us the issue. I don't know how well the camera can pick that out, but you can see the edge of the exhaust valve quite clearly here.
Yeah.
Whereas
Get that.
that's sort of quite a good step there, whereas that one is a bit less so. I don't know how well the camera can see that, but it's only half a mil, but that, you know, maybe that valve has got seating issues. So we'll take them, we'll pop a couple of valves out. I'll probably just pop the cylinder of concern valves out just for the demonstration, and then, you know, because it takes a bit of time to strip it all down and see if we can see our problem. What we're going to do now is remove the valves. The valves are held in the top with springs, and there's little keepers or collets or whatever you want to call them, little wedges that sit around the end of the valve, hold the cap in, and it all locks it into place. So we need to get those little collets out. So do that by compressing the spring while holding the valve in position. It pushes it, compresses it all. You can take the little wedges out, and the valve will pop out. So what I normally do is just give them a little tap, just to get things moving a little bit, and just because it's a bit easier with this particular one. This is a valve compression tool, and I'm using it.
So that looks very specific. That looks like it's designed for the job.
It's the only tool for this job. It's the only thing you can use it for. Or Clio 2 front anti-roll bar bushes is the other thing they're good for, but I don't do those. They're too new. Yeah, so that's what they are.
Oh, okay.
There are two different.
They're in half.
Yeah, they're in half. Two halves. There's different styles of them depending on the year of MG. Make sure you have the right valve and collet combination. I have seen them incorrect. The early ones have 3 ridges rather than 1, and you can get it wrong. And also there should be circlips on the early ones as well. I've seen engines that are missing the circlips.
And those collets are just held in place by the pressure of the spring. You don't have to.
Yeah, so you've got like a conical seat in the end, and that pushes against the conical wedges, and it all locks it in place. See, this engine I can tell has been apart recently as well, because it's got valve stem oil seals. That is a non-standard valve stem oil seal that you get in the aftermarket, which they do work better. It's rock solid, but the original O-ring ones weren't the best, and people always fit them incorrectly. They should be around here. They often, if people put them around the valve stem, and then they end up in the sump. So another check before you take the valve out is to grab the head of the valve and the stem of the valve, give it a wiggle, see if it's badly worn. There's a bit of wear in it, but it's not terrible.
So you ideally
it's kind of a feel thing.
You wouldn't want much movement in that at all.
No. So take the valve out. Yeah, okay, so I can see there in the face of the valve.
Oh, yeah.
All that pitting there.
Yeah.
So that's what we identified with the compression test. The compression test showed low on that cylinder. Put oil in the bore, did the compression test again, and it was still low. And so the oil seals the piston, but not the valve. And if you still have the same result, then it gives you an indication that it's the head. And indeed, we were right. Yeah, it's funny because I'm going to say that the engine was rebuilt. Maybe it's substandard quality valve or something like that. Well, it's about the seat then. But let me get a torch on that. You're recording, eh? Yeah. Yeah, so there's some pitting to the valve seat as well, although the valve seems to be the worst. I'm going to say it's unleaded. I can see an insert. You see, you've got that line that's further up the neck, and there's a line here that runs around the periphery, not where the valve was sitting on the taper, but further back, which looks like it's an insert. So someone's cut the seat out, put a hardened seat in, and then machined it to the correct size again. So that's good. It means it's unleaded. I don't have to worry about additives, etc. You can see this larger inlet valve than those who are familiar with MGs will see that that's the larger valve. I can't remember the dimensions, but Google. Loads of information on MGBs out there. So I'll take the inlet valve out now just for comparison. The inlet valve is always going to be cleaner because it's constantly washed with petrol from the carburetors. So by their nature, they're kept a lot cleaner. That's where direct injection modern engines have issues. You know, the petrol's fired into the cylinders and the valves get covered in blow-by gunk, and that one is stuck. There it goes. I find this an easier way to use the tool. I know it's not the way you meant to do it, but this one seems to work better like that. It's good for it. So similarly again, there's a valve stem oil seal. That feels okay. Quite a bit of black on it, to be fair. We can clean that up quite easily.
What would you expect?
Well, it depends how well it was running. There's some... yeah, I'd say that inlet valve hasn't been sealing very well either. Just wipe that. I'll do it quickly so you can see, but there's clean areas of the valve, and then you can see there's a difference there. There's a clean bit and a dark bit. See, it's dark.
Trying to
there
show
it's a bit
it.
cleaner.
Yeah.
Pick up the light a little bit. But again, that may well not have been sealing that well. You would expect a more consistent pattern. We clean all the carbon off of it, put lapping paste on it, lap them in, and that will give us a far better view of what's going on. So we'll do that now, and that'll be a good demonstration of valve seats. Pause it.
Yeah. Go.
So what I'm going to do now is just use the wire brush on the bench grinder just to clean some of the carbon off, just to help us lap them in. Okay, I'll give them a quick clean up just to demonstrate. So there's a bit of valve lapping paste. This is the inlet valve. So put a few blobs around the periphery. Because ideally we need to find out whether any of these valve seats will need any machining work. Use a valve lap tool with a sucker on the end. It's gonna be awkward now because I haven't cleaned the valve that well. Okay, pause it a second. All right, so with a bit of paste on the valve, the sucker on it. This sucker is not very good, so it'll be frustrating. Stick it on the end. You just do that, and it grinds it back in again. Up, down at a quarter of a turn. Do it again. Up. I would do if the sucker worked. I need new suckers. I'll do this for a demonstration. So it should show us, with any luck, condition should have done it a little bit more. But to be fair, I'm going to do it a bit more so you can see, because that's not very obvious.
Okay. Oh.
Don't worry about filming this bit, I'm just going to do it again.
That makes it looks quite good.
Yeah. Right, so you can take it out, wipe it off. That's lapping the valve in then, and that will help the surfaces match. You can see, well, for the most part around it, there's a nice clear silver band, which is the contact patch that we've been rubbing against on the head. There is a little bit of a divot there where something's gone in, but the rest of it is not all the way. So actually it would seal on the remainder of that. I will perhaps lap it a little bit more, but you probably get away with that without too much issue. We look at the head as well then, because correspondingly you're looking for that type of pattern. So nice, big, wide, consistent contact surface area. When that's shut with a load of spring pressure behind it, we have a nice gas-tight seal. So we'll do the same thing with the exhaust valve. We can prove the point that that's the issue. You can see it without even putting valve grinding paste on it. But, I'm going to fit. Yeah. A bit too big, that sucker, I think. So you're kind of pushing down at the same time as you're twirling. So you're putting some pressure on it, and as you come up, you do a quarter of a turn down, rub, push down, quarter of a turn down, and that helps draw the paste back in again and give you an even grind all the way around. Come here, you. Terrible. Terrible. Okay. You can see on this one all that.
Oh wow!
All that pitting.
That is
so
terrible.
I could see in the shape of it before I put paste on it, but it highlights it.
It does.
So all that exhaust gas has been blowing past the cylinder, and that's why when we pressurised the cylinder, blew air into it, and we could hear it coming out of the exhaust because of all this damage. So really, that needs another valve. That's not going to come back round again very easily. So the important thing is, what does the head look like? Not as bad because it's a hardened seat.
Okay.
It's taken less damage.
The valve is softer.
Yeah, I would say. There is some pitting to it. I would get another valve and really try and see whether it'll lap in. If not, I might be able to get that one redone. Sort of exhaust valve, valve seats, they cost per seat. So it may just be an issue with that valve seat only, in which case there's only one. If the rest are good, it looks like it's been rebuilt, not many, yes, miles ago, but not a lot. So that process you need to do with all of them, keep everything in a logical order, unlike my workbench, which is not. But we'll have make a map, put them all out one by one, and find out how many we need. So that gives us an idea of where our compression was going, and we can move forward with that repair. The next thing to do then is take the sump off the engine, have a quick look inside, maybe check a couple of bearings, see what condition they're in. With any luck, with the rest of it being gone through, they'll be in okay condition, don't have to worry about it. I did notice there's a groove in the crank where the seal sits. I know the camera will pick that out, but there's a line on the
Coming from the top
crank there where that's where the rear main seal sits, and the dirt and the oil has been rubbing against it in the one place where the seal sits, and it ends up digging a channel into the crank. So we'd have to. You can repair that by putting a sleeve on it, speedy sleeves. They're quite expensive, but they're cheaper than a crank by a long way. And this is it's a very, very thin shim, the circular that you can drive on, and then you peel the lip off, and it replaces that surface for the seal. So that's probably worth doing for that one. Okay, let's turn it over and see what it looks like inside. Okay, before we turn the engine over, we're going to take the lifters out. So the cam then goes around, pushes these up and down, which pushes on the push rods. As we take each one out, I'm going to check the bottom, check it for any damage, which gives an indication of the condition of the camshaft. That one's nice. It's a nice circular pattern on it because as the cam goes up and down, this needs to rotate. So that's nice, it's smooth, slight rotational scuffs, perfect. So let's put them. These must stay in the right order, so they're mirroring the block, and I will put them in something a bit more organised in a bit, but just for demonstration purposes. Yeah, that one's good. If you get them out of order, they're junk, because the camshaft will have mated in, each lobe will have mated into each one of these. And if you put it in the wrong one, you'll just chew the camshaft up. So it's cheaper to put new lifters in than guess. So ideally, you don't want to be running in a new cam. You have to run the engine at a high RPM for quite a while to bed them in. Come on. Okay. That one's stuck. Surprisingly, these are all in nice condition. Which is great, which again would go with the theory that it's been rebuilt. Yeah, that's okay. There's a little bit of marks on it, but it's pretty good. You're looking for little pits, pinholes. It looks like a real cratered surface when they go bad. Wow. I can't remember the last time I took an engine apart and they were like this. They're normally trash. Oh, yeah, see that one's just got the tiniest pit on it in the middle.
Yeah.
Pretty good though for a flat tappet. I'm gonna go get this one out of stock. If it's, they can get stuck if there's damage to the end of them. If it's failed and it's mushroomed the end, then it could be that that lobe is trash, but it can just get stuck sometimes. But it does feel like it's a definite stop. There's not much danger of it falling out when we turn the engine over, so it'll be alright. Alright, I'll roll it over now. So the engine stand. I've been unable to drain the engine because of the block drain, so it's probably going to make a big mess on the floor. So you're better to go this way because you can get the coolant will run out. Yeah, there it goes.
Wow.
That's a normal colour, right?
Is it? I was going to say, it doesn't look like a great colour.
Well, borne out by the rest of it.
Yeah.
Really. Need a longer bar. Okay, let's get the sump off quickly and have a look. Pretty sludgy.
Ew.
Some goop in there. Yeah, lovely. No bits, no chunks. But yeah, shows you what you don't get out when you drain your engine oil. That's why you need to change your engine oil regularly, because that, you know, I drained this engine when it was warm and there's still that in it. So nobody look at the lack of gloves. So I can see it's got a new oil pump in it for a start. When they're original, they tend to be the same colour as the rest of the block. That's quite fresh. We'll take the oil pressure relief valve out in a bit and have a quick look at that, because this engine was running on the gauge very, very high pressure. So there's a possibility that that's stuck. It'd be nice to find the reason as to why it was so high on the pressure. Where's the new thing to turn the crank? So if you look in the engine then, give you an idea. That's your movement at the other side. So the piston's going up and down. Now at the bottom, the cot rod's coming up. Again, someone's been here, they've marked it 1, 2, 3 and 4 on the con rods. Someone has had some care in the past. Going backwards and forwards, I don't see any journals that have an obvious rattle or anything. So we can we'll pop a cap off and have a quick look at a big end bearing. So yeah, while we're in there, we can have a look at the camshaft down the bottom. Again, the lobes look in nice condition. They're nice and peaky. There's a nice point to them, so it'd be interesting to see if it's been upgraded. But when they wear out, the pointy becomes less pointy, basically, and you kind of get like scuffing damage to the tip. But again, we would see that on the lifters if that was the case, that was going to be an issue. Okay. But to be fair, I don't see any other issues. You can also see with the pistons, they look very nice and shiny underneath, again indicating that it's had some recent work. So if we pop a big end bearing cap off, use a nylon one so you don't crash the threads. Some more. Left the bearing behind. Come here. Ooh, okay. Come here. So you can push the piston down. So oily, it's all stuck with the vacuum. Ooh, there we go. Oh, look at that. Okay.
What?
That's good. So when they come out of the factory, they have that light, pale surface, and then there's lots of different layers. I mean, that is the undriven side of the bearing. So when the piston is getting blown down by the compression, it's pushing on the other side. So, but that crank is in nice order. So you're looking for scoring, radial score marks. You can also look at the back of this and see this is a 10 thou. See 0.010,
Yep.
which means this crank has been machined down 10 thousandths of an inch, and these bearings are 10 thousandths of an inch thicker than the originals, so, you know, if this needs to be remachined because of damage, you can put slightly thicker bearings in, takes the tolerance out, it's good to go again. So we know that this crank has had some work as well, which is great. So just push it down enough that the con rod pop to the side. And get the other shell out. Without dropping it, damaging it. Great. So if you see there's slightly more wear in this one, and there's slight radial scratches in it, but that's going to happen as dirty oil goes through it anyway. But there's no deep grooves in it, and you would often see a copper colour, and that's the the sub-layer of the bearing before you get to the hard steel. You see copper, change them, saves you crank. But this one looks in good order. We can go through them again. You've got to check each one on each one, but that on initial inspection is good, which is all great news. We'll pop it back together again. Just for now, to keep it all in place. Now they have little tags in them, so they can only go in one way.
Oh yeah.
And that stops them from rotating in the journal. Otherwise, you can end up with the bearing spinning inside the journal. But you want them. So when the other one is bolted down, it can't spin. Always make sure you get every last bit of dirt off of them every time. Otherwise, you can end up inadvertently damaging the bearing by having a little bit of muck. Goes around at high pressure and high speed, and it'll just chew into your lovely crankshaft, which we don't want to do. Put those back. So lastly, as a demonstration anyway, I'll get the oil pressure relief valve out, have a quick look just to see if that's the cause of my very high oil pressure. It was reading 85 pounds at idle, which is nearly touching the top of the gauge on one of these, so the gauge only goes up to 100. Yeah, could be a faulty gauge. The coolant side of the gauge wasn't very good. I don't know. Just to check all the mechanical side of it first, and then go, okay, well, we'll try another gauge. So this is the oil pressure relief valve is in this side of the block in your car, because this engine's upside down, it'll be on your passenger side. Inside this dome, it's the domed nut, basically. Behind the domed nut is a spring and a pressure bucket. So when the pump is pumping, it gets to a certain pressure and opens. So it's like it regulates the top end of the pressure. Oh yeah, that's stuck. So there is it in there somewhere. I'll try and get a magnet in there, but I don't think it's going to do it. If that is stuck, and it won't. Oh, there it goes. No big damage or anything obvious to it. Again, they end up with scoring. It does feel quite rough, actually. Yeah, that's really. I can feel this. I better hear it, but.
Yeah. Yeah, you can.
So that I put another one in it and tried again. And I was half expecting to see a lot of washers in it. You can, in desperate times, if you have a low oil pressure engine, you can put a quarter washer in there to pack the spring out to give it slightly more pressure so it doesn't blow off as early. But yeah, I was wondering if that was a possibility. Another thing when the spring's out is to measure the free length. From memory, it should be 3 inches exactly. If it's too little, then again the valve opens too early, you end up with low oil pressure issues. So whenever you take one apart, you always measure it against the spec. But that feels like a rough, cheap copy, I would say, with the machining on it, so that might be the issue. So there we go, that's kind of it for the teardown and assessment. Hopefully there's a few things in there that were interesting. We can continue to take this apart and just double check the main bearings and things, but at the moment I'm fairly happy with it. Bottom end looks to be good. It just looks to be, for some reason, a valve seat issue there. So easy fix. The biggest issue is going to be doing the bodywork on this car. It's now in very stripped down condition. Have a quick look before we sign off. We're now at that stage. So wings are off, all the suspension's off. We've only got the dashboard and the wiring left to take out, and then it'll be mounted on a rotisserie next week, and we can start getting the welding sorted. So it's been coming on. As some of you have said in the comments, it's a brave one, but you know, if we can't fix it, no one can. So that's the fun oily bit for me. I'll leave this bit to Ayla, who does the welding with me, and hopefully we'll start to see some progress next week on getting the Marley done. So thanks very much. Comment if you can, like, subscribe, all those YouTube things. Bye.